Hello, my fellow mathematician. Welcome to the study of OD1. We are looking at second order differential equation with the constant coefficient. And today we are focusing on the non-homogeneous case. So, non-homogeneous case constitutes of the complementary part and the particular part. So, today's focus it is to finding the particular solution. So to find the general solution of homogeneous of an homogeneous ODE of the form f of d, which is equal to Rx, there are several methods we can apply. So we are going to consider three, which are the most used method. Number one, undetermined coefficient. Number two, variation of perimeter and inverse D operator. For the purpose of today's presentation, we shall only focus on the first one, the method of undetermined coefficient. So this method works only when Rx is of the form, number one, Rx is a polynomial function like this one, like f of x is equal to x squared plus 2x plus 1. That is a polynomial function. Number two, Rx is the function of the form ex. For instance, you could have a function like f of x is equal to 2 exponential 2x, or you would have a function like f of x is equal to 4 exponential negative 3x plus 1. So that is the function. Sin m of x, for instance, you would have a function like f of x being equal to 2 sine of x. That's form. Number three, cos of m of x, you would have a function of this f of x is equal to cos of 3x, a function of that form. And number three, Rx is equal to the function of sum or a product of the functions in 2 and above. For example, you could have f of x being equal to sine of x plus 2 cos of x. So this is the sum. For the product, you would have something like f of x is equal to 2x sine of x. So this is a product of the function above of these two functions. Now, a simple example. Here you are going to solve the following differential equation by the method of undetermined coefficient. So you are given second derivative of y plus 4y is equal to 4 exponential 2x. So this has two parts. Part 1, the reduced form of part 1 will give you y second derivative of y plus 4y is equal to 0. So here we let y to be equal to exponential mx, whereby now our auxiliary equation will be m squared plus 4, which is equal to 0. So m is equal to plus or minus 2i because it is a complex part. Whereby now our complementary solution will be given by yc, to stand for complementary, is equal to a sine of 2x plus b cos of 2x. Whereby now a is a constant and also b is a constant. So to obtain the particular part, we consider the form of Rx as follows. So we let our yp to be equal to a exponential 2x. So from this equation which we are given, we substitute our y here. Where you have y, you substitute it there. Then you differentiate this twice. When you differentiate this once, you will get 2. The second derivative now you will get 4. That way, you factor exponential 2x both sides. Here you want 4a plus 4a to get 8a. Then you can divide by exponent 2. Both sides to be left with the 8a is equal to 4, whereby a now is equal to half. So the particular part will be given by half exponent of 2x. So the general solution of the ODE reduces to, so the general solution is given by y complementary plus y particular, whereby now you add the two to get the following as your result. You add this y complementary plus y particular to obtain your result as shown here. A and B are a constant. So that is how you tackle it. So in the subsequent video, I am going to give you a number of examples so that this method becomes easier for you. Thanks so much for learning with me. If you have not yet subscribed, kindly consider to do so. Also like and share with the other mathematicians so that we may learn together. Bye bye. See you in the next video.